Alright, so for this video we're running the OCC-X Dual. We're running a CPU head and a GPU head. On the left hand side of the screen there you see the CPU head. That CPU head is mounted on Intel 5960X on the RVE Vantage 5 Extreme motherboard. Just to the right of the CPU head there you see the GPU head. The GPU head is mounted on the Extreme Cooling GTX 980 Ti. A couple of things that I want to explain about the OCC is it is running inside the purge case. So what's happening is the liquid nitrogen is being delivered down to the two heads there. It's being controlled by a process controller. We're monitoring the process controlling on our tablet. So basically what happens with the OCC is we set the temperature either to the GPU head or the CPU head, and the OCC takes care of the rest. There's no pouring, there's no propane torches. The OCC is running, as we said, inside the purge case, and inside the purge case there is zero ice. So there's also zero insulation on any of our equipment. It's a good thing if you burn up a board or something like that and you want to return that board. If you return it with your insulation on the board, there's no RMA. But if you return it with a board that's been run inside a purge case, there's no sign of extreme overclocking on the board. So you can go ahead and get yourself a new board, new chips, new GPUs, whatever it is. Anyway, so we're going to move ahead. We're going to be running the Intel 5960X at about 5400 megahertz at about 1.6 volts. We're running the Kingpin GTX 980 Ti. This is an 80 plus card, and it's running at somewhere around 1600 megahertz on the GPU clock, and then somewhere near 2000 megahertz on the memory clock. And then with that, the GPU voltage is at about 1.5 volts. The GPU memory voltage is at about 1.8 volts. We don't have an EVGA yet, so we can't control the PLL voltage or the other voltages. All that we have access to is through classified. So anyways, we're going to go ahead and run this benchmark. It's about 10 minutes long, so you can kind of skip ahead or skip around. What you see there is the tablet. That is monitoring temperatures on the OCC. On the left-hand side, you can see your CPU and GPU temperature set points. On the right-hand side, you can see the CPU and GPU actual temperatures. So we're going to go ahead and get started. First of all, we're opening up CPU ID. We're going to just verify the clock and voltage. So the CPU voltage is at 1.626. The clock is at 53, about 53 and a half. The opening up here, Precision X. The GPU clock is at 1661. GPU voltage is at 1.5 volts. We're going to go ahead and open up Tech GPU Z. In Tech GPU Z, we'll see the actual megahertz of the GPU memory clock. It appears that the actual megahertz of the GPU memory clock is at 1907. Now we're going to run the benchmark. Enjoy, and like I said, pay attention to the temperatures. This is a pretty stress-worthy benchmark. It gets your CPU and GPU hot, so you'll watch the OCC responding to that heat. As the heat load rises, the OCC delivers more liquid nitrogen. As the heat load falls, the OCC delivers heat through heaters in the heads. So you don't ever go past your cold bug, and you don't ever get too hot, because in one situation or another, the AUK is responding with either liquid nitrogen or the heaters that are inside the heads. So as you can see there, the temperature has gotten knocked down or heated up about like it went down about 8 or up about 8 degrees, and the AUK is in response delivering liquid nitrogen. Now it's catching back up and getting back up closer to the set point. Mind you that while the graphics test is running, the AUK is at sometimes delivering lots of liquid nitrogen. At other times, it's delivering heat. So right now, rather than going down past the cold bug, which would be maybe 74 or 75, as I said before, I can't change some of the voltages that need to be changed to lower the cold bug on this GPU. But as it goes up towards 73, rather than delivering too much liquid nitrogen and hitting 74 or 75, it'll add some heat. Or when the AUK senses the temperature rising, it begins again delivering liquid nitrogen. So now you see it's going back down to about 68. There's a lot of stress on the GPU, up to 6970. I think we have one more graphics test, then some CPU physics tests. So this next graphics test, and as you can see, here's another thing: is the GPU head right now is delivering a mass amount of heat because it was filled up with liquid nitrogen. As you can see, it went all the way to 77. So now it is knocking it back down, and boom! Rather than going below too far, the AUK probably has already started delivering liquid nitrogen. We're back down to 72, or back up to 72. It's doing its job. Good thing about this is if you're an overclocking bencher, you can focus completely and entirely on your computer system. The AUK requires no monitoring of temperatures. So you can see how your computer's running. You can watch the codes during boot. You don't have to do anything to keep your computer cold because the AUK does that for you. You don't have to do anything to warm it up like you would with the propane torch, because the AUK does that for you too. So. There's two trend lines that you see on the right of your screen there. Those trend lines are showing what's happened with the temperature. The straight line that you see is the set point. As you can see, the CPU is set at minus 113. That's that lower line, the green line, and the CPU temperature is being held right there by the AUK. The upper trend line you see is the GPU temperature. As you can see, when the benchmark began, that first trend line jumped up because it added a lot of heat immediately, and the AUK then began to respond and add cold. But you'll notice during that first benchmark, the entire time during the benchmark, it never added too much cold, and you can see some variations where the heat went up and down before that second dip. That second dip is in between the two benchmarks, while the GPU was full of liquid nitrogen, so you lost about 3 or 4 degrees. Temperature dipped down. I think it went to 76, and so what was happening during that dip right there is the AUK was delivering heat through the heaters to heat it up. So anyways, I'm pretty sure we're about to run the CPU physics test. This is I can't remember the name of this one, but as you can see now, the CPU temperature is rising, 108. And the AUK is delivering liquid nitrogen during this time. The OCC runs independent of the tablet. All of the logic for the OCC and the temperatures, so on and so on, that's all inside the controller, the OCC controller. Whereas the tablet is just there at this point to do set points and monitor temperatures, make it a little easier to see what's been happening with your temperature as time goes on here. Alright, so that's the end of the benchmark, and as you can see, pretty lucky score, 77707. Oh, that's kind of weird. Anyways, so drop us a line. We respond to all the comments we can, and those ones that don't use foul language, just kidding. Yeah, anyways, visit us on lnlcooling.com. You can also see a couple of exposés that overclocking-tv.com did on their website for us. And you can visit the HWBot forums. We're on there in a couple of different places, and also we compete a little bit on HWBot. Bye-bye for now.